In this video, I will introduce component form of a vector. So starting with this vector right here, remember that we can represent this vector with this notation. And now for component form, we use these funny angle brackets, and you want to think of it as how far over in the x direction to get from P to Q, and how far up. How far up in the y direction to get from P to Q. So now let's start with the how far over in the x direction. So P is the point, -1, 2, and Q is the point 3, 4. Drawing a right triangle, we can see that getting from x equals -1 to x equals 3 is represented by this distance here. And you're probably saying, okay, well that's 4, and you're absolutely right. And a way to figure that out all the time is to take the x-coordinate of the terminal point, in this case 3, and subtract the x-coordinate of the initial point, in this case -1. And notice that in fact 3 minus -1 is 4. So now how far up? Oops. To compute how far up, we want to say how far do we have to go up from y equals 2 to y equals 4. And that's that distance there. And so you're saying, okay, to get from 2 to 4, that's 2. Absolutely right. Again, and in general, the way to do this is to start with the y-coordinate of the terminal point, which is 4, and subtract the y-coordinate of the initial point, which is 2. And now doing the math here, we see that 3 minus a -1 is 4. 4 minus 2 is 2. Now let's compute the component form of vector OR, where O is the origin and R is this point, 4, 2. Again, drawing our triangle, we see that the x distance is 4 and the y distance is 2. So how far over? 4. How far up? 2. And you can see that these two vectors are the same, are equal. They have the same component form, and so they're equal. And this just verifies again what we learned in the previous video, that these two vectors are in fact equal because they have the same magnitude and direction. And what this shows is what component form is actually doing. So finding the component form of this vector finds an equal or equivalent vector whose initial point is the origin. So what component form does is it finds an equal vector whose initial point is the origin. Now let's find the component form of vector ST. Now, S is the point -1, -1, and T is the point -3, 2. And so here we're going to compute how far over, how far up. You could do this just by visualizing it, but you want to make sure that since we're moving in the negative, since we're moving to the left, that your overall answer is negative. Right, so it would be tempting to say, okay, how far are we going over in the x direction? So we're going from -1 to -3. So how far is that? That's a distance of 2. That's a distance of 2, right? From -1 to -3, that's a distance of 2. But that wouldn't be correct for the component form because we're traveling in the negative direction. We're starting at -1 and we're moving to the left to -3. So the correct answer, see, we're moving this direction, would be a negative there. So -2 there. Now, how do we get around having to worry about this? We always just do the same thing every time. And that is, we take the x-coordinate of the terminal point, in this case -3, and we subtract the x-coordinate of the initial point, in this case -1. Similarly, to find the y component, we take the y coordinate of the terminal point, in this case 2, and subtract the y coordinate of the initial point. And so here, let's see, -3 minus a -1, that's -3 plus 1, or -2, and 2 minus a -1, that's 2 plus 1, or 3. And let's just verify real fast that we did in fact go up, right? We do move up from, so we do go up. And how far do we go up? We go from -1 to 2, that's 3, so that's why we have positive there. But you never have to worry about that if you always do it the same way, and that is x-coordinate of terminal point minus x-coordinate of initial point, and then for the y component, y-coordinate of terminal point minus y-coordinate of initial point.